Okay, hi, good morning. Just check whether I'm audible. Is the voice clear? Can we start? Write it in the chat box. Write it in the chat box whether I'm audible and can we start right now? Okay, hi, good morning all. So what we had seen last time was we had gone through some basic things and we saw that there are something called as charged particles, and those charged particles are nothing but called as ions. So last time we were trying to complete this point, right? And today we are going to go with some different point, and that is going to be about chemical effects of electric current. So what we are going to understand today is the topic name is chemical effect of electric current. So basically this is the title of our lesson, and now we are going to go into the details of exactly what is the meaning of chemical effects of electric current. So let us just see what is that. So chemical effects of electric current. Okay. Now can I change the letters? Can I change the letters? Suppose let's say if I write it down as chemical effects of electric current, place of electric current, I can write down electricity, right? Because after all, electricity is the energy and electric current is nothing but the flow of electricity, right? So that is, if the electricity is flowing, so that means it is electric current. So I can write it down in place of electric circuit, electric current, I can write down electricity. So in short, I can write it something like this: chemical effects of electric current. So can I say chemical effects of electric current is nothing but chemical changes? These are effects, means what? Chemical changes. Okay, so can I also write it something like this: chemical, I will just write down, see, I am making just changes so that you can understand what it really means. Chemical changes of electricity. Now are you understanding? It's a very simple definition of the particular word chemical effects of electric current. In simple words, it means these are the chemical changes which are happening due to electricity. So electricity is bringing about these chemical changes, but chemical changes can be also written as, they can be written as chemical reactions. Okay, chemical reactions. So can I say one thing, that chemical reactions, suppose let's say if they are happening due to passage of electricity, so if electricity is flowing and if it is producing chemical reaction, then it is called as chemical effects of electric current. Are you understanding this point? It's a very simple term. इसका मतलब simply इतना होता है कि chemical reactions, if they are happening due to electricity, then we are saying that is nothing but chemical effect of electric current. ये समझ में आ रहा है? Are you understanding this? Write it in the comment section. Are you understanding this? That what exactly is the meaning of it? That chemical effects of electric current is nothing but if the chemical reactions are happening due to electricity, then it is called as chemical effects of electric current. So let us just say we will have some example. For example, if you are taken one container, and you have added some water inside it, okay, you have added some solution, suppose salt solution. So you have salt solution inside it. Now, if you add, suppose let's say if you pass electricity through this, then what is going to happen? Electricity is going to flow through it. Chemical reactions are going to take place in this. So we can say it is undergoing what? It is undergoing chemical reaction. It is undergoing chemical reaction because of the energy we supplied. We supplied some energy, electricity, and hence it can be said as chemical effects of electric current. Okay, so this is the first point. Are you understanding? Chemical effects are nothing but when electricity is passed through the liquids. For example, these liquids. So in short, how can we write it? We can say when electricity is passed through the liquids, different chemical changes takes place. When electricity is passed through liquids, different changes take place. different chemical changes takes place, and that is called as and that is called as and that is called as chemical effects of electric current. Are you understanding the definition? When electricity is passed through the liquids, different chemical changes are going to happen, and that is called as chemical effects of electric current. Okay. And but suppose, let us say, this liquid which we are using, this liquid is called as electrolyte. As you already know, if a certain liquid is able to pass or is allowing electricity to flow through it, it is called as electrolyte. So this liquid which we have taken, the salt solution, our salt solution is nothing but an electrolyte. Agreed? Salt solution is nothing but an electrolyte. So can I say one thing? Can I say one thing? That for chemical effects of electric current, we will do one thing. See, we will use one short, suppose let's say a short form for our understanding, right? We will just say chemical effects of electric current as chemical effects of electric current. Okay, of electric current. Of electric current. Is it fine? In short, chemical effects of electric current. Okay, in short, we will use something like that. So, can I say for chemical effects of electric current, can I say that the liquid should be electrolyte? A liquid should be electrolyte. Otherwise, the electricity is not going to pass, no chemical reaction, nothing. So, liquid should be electrolyte. Agreed? Write it in the comment section. Are you agreeing with this point that liquid should be electrolyte? Unless and until it is electrolyte, electricity is not going to pass and we are not going to get chemical reaction. Agreed? Okay. So now there is another method. Now this is a chemical reaction. This is basically a chemical reaction. So we need to give it a name. We need to give it a name. So this chemical reaction which we are seeing right now, that is called as, this chemical reaction which we have seen just right now, it has a name. It has a name, and it is called as electrolysis. Electrolysis. Now what is the meaning of this? Let us try to understand what is electrolysis. Now the complete meaning of that word is not given in your syllabus. So what we are going to do is, we are going to understand it in a short way as possible. So let us just write down electrolysis. Electrolysis. ठीक है? Please understand this word very carefully, because this topic is again there in your syllabus in 10th standard. In 10th standard it is available in 9th standard. So I would recommend you to understand this concept very well. So after you write down this word, you can divide it into two. You can divide these words into two. See, I have divided the words into two. Okay. What is the meaning of electro? What is the meaning of electro? Electro means electricity. Electro means what? Electricity. Okay. And what is the meaning of lysis? Lysis. Meaning of lysis is breakdown. Lysis of meaning is breakdown. Okay. So can I say the meaning of electrolysis is nothing but breakdown due to electricity of any material or any liquid is called as electrolysis. So basically, but we have seen examples of liquids only. So we can say, we can use this definition. Electrolysis is the breakdown of liquids due to electricity. Are you understanding this? Okay. So that is your definition. So you can do one thing. You can either use the textbook definition that what you have, or you can even use this one. You can use this one if this is what you feel is easy. You can definitely use. Electrolysis is the breakdown of liquids due to electricity. That's it. ठीक है? Okay. Now let us talk about another point. Now we have to see the difference between chemical effects of electric current and electrolysis. What is the difference between the two? What is the difference between the two? Right? We have to see this. Electrolysis is nothing but a chemical reaction. Electrolysis is nothing but a chemical reaction, right? Breakdown reaction, chemical reaction. Okay. And what is this? What is this? This is just breakdown. This is just chemical reaction which is happening. Okay. So basically this is just the changes which are happening. Changes which are happening. Changes which are happening. Are you understanding the difference between the two? Chemical effects of electric current, these are just the changes which are happening inside a liquid when we are passing electricity, and electrolysis is nothing but the name of the chemical reaction. So can I say chemical effects of electric current, chemical effects of electric current are giving rise to electrolysis? So in short, chemical effects of electric current are giving rise to electrolysis. So can I say this is the cause, like, you know, this is the reason why, suppose let's say cause, and this is the result. This is the result. Effect, you can say, result or effect. So in short, electrolysis is nothing but a chemical reaction, and these are the changes which are happening. Electrolysis is just a chemical reaction, that's it, nothing more. So one is the cause, another is the effect. So who is the cause? Chemical effects of electric current. And what is the result? Electrolysis. Are you understanding this? Okay. Now let us go with, suppose let us say, but even in short, if you want to write down, I know you are just in 8th standard, you are just little kids, so it's very hard to remember both of them. So I will just give you a short trick how to remember this. For electrolysis, you just say it's a chemical reaction. For electrolysis, you just say it's a chemical reaction. Okay. And for chemical effects of electric current, how can we define it? You can just write down, it is the phenomenon of electricity. It is the phenomenon, okay? Phenomenon of electricity. Now is it fine? That is the most simplest way you can define both of them. Okay? It's a chemical reaction, it's a phenomenon of electricity. Is it fine now? I think it is totally fine. Okay, now let us move ahead. Okay, now to have that electrolysis, we are trying to break down two substances, right? Basically, the liquid is going to be decomposed, it is going to be, suppose let's say dissociated, it's going to be divided. So how can we do that? So first you have to take a container. First you have to take a container. Let me take, suppose let's say a big container, right? Okay, so we should be having, suppose let's say a bigger container as such. So this is my container. Now I am going to add, suppose, some liquid inside it, some liquid. Okay, that liquid must be electrolyte. As you know, the liquid cannot be, suppose let us say, just a normal liquid. It should be electrolyte. Agreed? It should be electrolyte, without which it is not possible. Okay, so please write down the name of this. This is electrolyte. Electrolyte. Okay. Now, what I am going to do is, to pass electricity through this, you already know electricity has 2 points, right? Positive and negative charge. So even if you show a battery, you are going to require positive and negative charge. So battery can be shown something like this, with this symbol, with positive and negative terminal. So this is positive, this is negative, and then this you can connect to your regular cell. For example, this is my battery. I can connect this to my regular bulb like this. So this is my bulb. Okay, this is my bulb, it is glowing. And I can connect that same bulb to my circuit. This is the one. So what is this? This is the battery I am talking about. This is the battery. And this is my bulb. So in this way I have connected. So you already know there are two positions, that is positive and negative. So that means even in this reaction we are supposed to show positive and negative. If you want to use electricity to break down this liquid, you need positive and negative terminals, right? Okay, so what we will do, we'll put two metal pieces in that. We'll We'll put what? Two metal pieces inside it. These are metal pieces. Okay, the golden colored rods which I have put, those are basically what? Metal pieces. Okay, why I am using this? Because I want to pass electricity to through this liquid. Only then breakdown is going to happen. So what I am going to do, I am going to connect these metal pieces with my battery. I am going to connect these metal pieces with my battery. So let me just connect them. Let me just connect them to my battery. Okay, so this is my battery here. Positive, negative, positive, negative. Okay, and I have connected the another terminal to negative. So positive and negative. I have connected one terminal to positive electrode of 1 and electrode 2 I have connected to negative. So this is my electrode 1 and this is my electrode 2. So basically the metal strips are called as electrodes. Metal strips. Now you have to always call them electrodes. Electrodes. So what are electrodes? Electrodes are nothing but, let me just give you a definition for electrodes. Electrodes are the metal rods, or metal strips. It can be strips also. It doesn't need to be a rod, it can just be a piece also. So or metal strips used in chemical reactions, used in electrolysis, basically used in electrolysis. They are nothing but metal rods and metal strips, nothing more, those electrodes. Okay, so but we already know there is one positive, one is connected to positive and one is connected to negative, correct? And we have names for it. We have names. If the terminal is connected to positive, if connected to positive, then that is called as anode. Then that particular rod is called as anode. Okay, that is called as anode. So out of these two, who do you think is anode? Like, you know, we have two electrodes, right? Let me give it a name. Let me call it A. Let me call it B. Who do you think is connected to positive? Who do you think is connected to positive? Positive is connected to, you can see positive is connected to A. So positive is connected to A. Okay. And if it is connected to A, what do we call the rod which is connected to positive? We call them anode. We call them anode. So in this case, A must be anode. A is anode here. A is anode because it is connected to positive. What about B? What about B? So you have to always remember, if any rod is connected to negative, then it is called as cathode. It is just a, suppose it's a name which is given in our terminology. It doesn't mean something special. It is just a simple logic that when your rod is connected to positive, it is anode. If it is connected to negative, it is called as cathode. So it doesn't carry that much of information. It doesn't have a very large explanation. It's a very simple logic that if a rod is connected to positive, it is anode. If it is connected to negative, it is cathode. Okay, so that is just a way we try to give it a name. Now what about in this particular experiment, like the one I have shown? In this case, who is connected to negative? Who is connected to negative? B is connected to negative, right? You can see here, negative is connected to B. So that means B is what? B is cathode. B is cathode. Okay, I hope these 2 points are clear. Positive is anode, that is A, and B is cathode. Okay, now what we'll do is, we will just have two arrangements and we'll try to understand who is which electrode, right? Okay, so I will just draw the first diagram. You tell me if I am taking some liquid inside it. I have taken two electrodes. Okay, and I have connected them to my battery. Okay, and suppose the names I have given for these rods are, this is rod M and this is rod N. According to the figure, who do you think is going to have positive charge? Who is anode and who is cathode according to your information? Just write it in the comment section. Write it in the comment section, that will be more than helpful. You tell me who is anode and who is cathode, who is positive charge and who is negatively charged, who is cathode. Just write it down in the comment section so that I can see. Write it in the comment section, I will be able to see those. Okay, so basically A, correct. Exactly. So in this case, rod M is, yes, rod M is positively charged. Rod M, electrode M. Just let me write it down properly. Rod M is positively charged. It is connected to positive. Okay, not positively charged, we have to say connected to positive. And if it is connected to positive, in short it means it is anode. Okay. Same goes for rod N also. Rod N is equal to, it is connected to negative. Okay, so hence it is cathode, right? It is cathode. Now can we do one thing? Can we have another arrangement in which you can tell me, suppose let's say which rod is which? Can we go for another arrangement? Can we take some example from 10th standard? Will you be able to solve? just for your excitement, I am willing to give you suppose let's say a question from 10th standard, just to identify which are the rods. Will you be able to do it? Just tell me in the comment section. Are you interested? Just tell me in the comment section so that we can start. We just have to identify which is anode and which is cathode. That is what I am asking you. Is it fine? Okay, so that is fine with you. If that is fine with you, then I can definitely start. No issue. Okay, so let me give you the particular picture, and then suppose let's say you can try to find out. A simple question from 10th standard, nothing more, not that much difficult. Okay, just 1 minute. So this is the question. Okay, I hope everybody is able to see the question. Okay, you just have to identify, suppose if I give this rod A, if I give this name rod A, and if I give this rod B, can you tell me who is anode and who is cathode? That will be more than sufficient for this question. Okay, who is anode and who is cathode? You can see A is connected to positive. A is connected to positive. So that means A must be anode. A must be anode. Right? Okay. And B is connected to B is connected to negative. B is connected to negative. So that's why B must be cathode. B must be cathode. Okay, so that means you are able to identify now. Very good, very good. Pranav correct, Gayatri correct, Suhani correct, Vedant Zadav correct, Shlok correct, Chandrakant Lakhamwad, that is wrong. Bhumi correct, Vasudha correct, Aditi correct, Gayatri yes, Bhumi Agarwal, Kaushal correct, Shantanu, yes. So that means that's a very simple logic. A is connected to positive, so A is anode, and B is connected to negative, so B is cathode. I think the concept is very much clear now, right? B is connected to negative. B is connected to negative. Shantanu Thorat, B is connected to negative. You can see there is the negative terminal here, right? It is negative. So that's why we are suppose let's say B is nothing but cathode. B is connected to negative, positive is here, negative is here. You can just yourself check. Okay, take it. So can we move ahead now? You must have understood everything. Okay, take it. Now we have to understand the next concept and then we will end it. Okay? Can I go with it? Okay, take it. So let me just give you one understanding of the last part and then we'll end our session for the day. Just the last part, just a simple one part which I want to explain. Okay. Okay. So this is the one. Okay, so let us understand this. So what we have is, we have been given anode and we have been given cathode, right? Let me just make it as much short as possible. Okay, so this is the figure which we have been supplied with. So can we say that this particular figure what we have, this is nothing but one, it has anode, it has cathode, right? This whole arrangement, this whole anode, cathode, battery, everything, that is called as electrolytic cell. That is called as what? Electrolytic cell. Electrolytic cell. Okay. Okay, so how to suppose, let's say, define it? Electrolytic cell is nothing but apparatus. It is nothing but the apparatus. This is whole is nothing but this is nothing but apparatus. So you are going to say electrolytic cell is nothing but apparatus. It is the apparatus which consists of consisting of what it has. First it has electrodes, right? First it has electrodes. So write down electrodes. What another thing it has? That liquid is called as electrolyte, right? Apparatus consists of electrodes, electrolyte, and the vessel, the container also, and the container. So you are going to write down and vessel is called as electrolytic cell. Is called as electrolytic cell. Okay. Are you understanding the definition for this? Electrolytic cell is nothing but apparatus consisting of electrodes, electrolyte and vessel is called as electrolytic cell. So the whole arrangement is called as electrolytic cell. So that means this is electrolytic cell, this is also electrolytic cell, this is also electrolytic cell. So it consists of only three things. Which three things? The first thing it consists of is electrode. The another thing it consists of is electrolyte. And the next thing it consists of is the vessel in which we have carried out our reaction. So these are the three things which are, suppose let's say, included in our electrolytic cell. So this is called as apparatus. All these things are nothing but apparatus. It comes under apparatus, and all that apparatus is called as electrolytic cell. Are you understanding the definition? Very simple one. Three things comes in that: electrodes, electrolyte, vessel. Okay, so just write it down in the comment section whether you have understood this. Okay, so in the next session, what we are going to do is, we are going to learn about electrolysis of water, and then we will discuss about which gas is released at anode and which gas is released at cathode. That we'll discuss in the next session. Fine? Are you understanding this? In the next session, we'll be talking about which gas is released at anode and which gas is released at cathode. Fine? Gaurav Gadam, have you understood? We'll talk everything about this in the next session. Okay, so we will end our session for the day here, and in the next session we will see which gas is released on anode, which is released at cathode, and electroplating. So both the concepts we'll see in the next session. So thank you so much for today. We'll meet on the coming Friday for the next session. Thank you. Bye-bye.